joining us today. My name is Alexis Wolf, and my colleague and I, Shannon Zarrett, and our other team, thank you so much for joining us. We are the BioenergizeME team, and today we will be talking about the 2017 challenge and kind of going through the different topic areas that are part of this challenge. So there we go. More in detail, I'll talk a little bit about the ground rules of the 2017 challenge, which if you've participated in the past are pretty similar, but we have added some new rules this year that you want to take close attention to. And then some important dates that you should be attentive to. As well, I will go through each of the topic areas, history of modern bioenergy, sustainability, bioenergy and society, workforce and education, and science and technology, and give you some helpful hints on how to get started with research and some information that is pretty crucial to know to answer some of the questions, as well as wrapping up everything with talking about some of the resources that will help you get the research process started. So, during today's webinar, please record any questions or comments you may have into the little chat function of the GoToWebinar, or you can submit them to the email that's listed on the screen, which is bioenergizeme@ee.doe.gov. And, you know, at the end of the webinar, if we have time, we will definitely go through and see if we can answer any of your questions. And if you have any additional follow-up questions or general inquiries about the 2017 challenge, please feel free to email us at any time. So you can find today's webinar recording and slides on the Bioenergy Technologies Office website in the location that's shown on this little screen. As well, the webinar will be available shortly in the Educational Resources section of the Education and Workforce Development website for easy access. So moving on to the actual 2017 BioenergizeME challenge. So the next 10 to 20 years is going to be about children and young adults making decisions about how bioenergy will be implemented into society to become much more than just an energy source. And one way that the Department of Energy's Bioenergy Technologies Office is addressing this age group is through the BioenergizeME Infographic Challenge. The overall goal of the competition is to enable students to be better, more informed consumers of energy information and to have the ability to dispel energy myths they may encounter in the media and other sources of information. Knowledge is power, and gaining foundational wisdom on bioenergy will assist them in becoming more informed leaders of tomorrow. More information on the background of how we developed the BioenergizeME challenge, what it's based off of, which is the X Prize model, as well as some general information about bioenergy that may be informative, can actually be found in the BioenergizeME Infographic Challenge Toolkit. So let me get started by telling you the steps on how to compete for this grand prize title. So the first step is to register a BioenergizeME team. And the challenge is designed for teams of 2 to 6 high school students in grades 9 through 12. Team advisors can adjust the team size as needed for their teaching situation, but only students and 2 advisors or chaperones from the winning infographic team will be hosted at the Bioenergy Technology Offices, or BETOs as I'll refer to it later, annual Bioenergy Conference in Washington, D.C. All entrants must be U.S. citizens or legal residents and over the age of 13 years. A participant may not have reached his or her 19th birthday as of January 1st of the year in which the challenge winners are selected, so that would be 2017. However, the BioenergizeME team may grant a special authorization to compete for youth with developmental disabilities who exceed the upper age limit. A team advisor must approve each submission. This is crucially important. And we encourage team advisors to integrate the challenge into the curriculums where it fits best for them, but you should keep in mind the submission deadlines and the social media campaign schedule. A team advisor must approve each submission. Again, the challenge can also be used, though, in an informal learning environments, including after-school programs, clubs, and organizations, extracurricular groups, recreational groups, nonprofits, you name it. So advisors must sign up for their teams using the registration form that's on the Bioenergy website. At the registration page, advisors will be asked to provide their name, email address, and how many teams they are registering. But please note that advisors can register more than one team. So first important date, we encourage teams to register as soon as they are formed, but all teams must be registered no later than Friday, February 3rd, 2017 by 5 p.m. Central Time. So a team's infographic should respond to one of the 5 research topic and prompts provided in the annual update. Students should make sure their infographic communicates a well-focused thesis. And this is all covered in the 2017 annual update, which is shown on the screen. Approaching the research process with the plan in mind will help give direction to a team's efforts and help stay focused. So with that in mind, the BioenergizeME team has compiled a group of resources to assist teams in developing a strategic plan for their research efforts, as well as identifying peer-reviewed academic or professional sources in this BioenergizeME Research Resource Guide. And just as a note, all of these resources are available on the BioenergizeME Challenge website. The internet can be a really valuable tool for research, but it is really important to verify that your sources of information about bioenergy are both credible and timely. The BioenergizeME Research Resource Guide is a comprehensive list of reliable resources to provide a foundation for students to begin their research. And some of these sources include valuable publications, fact sheets, and reports from a variety of organizations, such as government agencies, national laboratories, research centers, and major academic institutions on the leading edge of science and technology research. So to facilitate the review process during the first round, which I'll cover shortly, the BioenergizeME team strongly recommends that students use the resources provided in this guide to generate the content for their infographics. This will enable the reviewers to check infographics in a timely manner and ensure students will have ample time to make the necessary revisions. Teams are more than welcome to use resources not included in the resource guide as long as they are from science-based or peer-reviewed sources, such as local, state, and federal government agencies, national laboratories, research centers, academic institutions, science journals, and others. So our office collaborated with the Library of Congress to develop a collection of quality resources for the BioenergizeME Challenge. These resources provide a solid foundation for conducting bioenergy research. The Library of Congress, just so for your information, is the world's largest library by number of cataloged items and serves as the research library for the U.S. Congress. The Library of Congress developed this research strategy guide and provides students with a starting point for their research and provides guidance on developing a successful research strategy. This document is available on our website as well. There's also the really cool feature where you can ask a librarian to get research assistance from any of those Library of Congress librarians. And feel free to use any of the information that we talk about in this webinar as well to help with designing infographics, as long as you correctly source the information. So the third step is to actually design a BioenergizeME infographic. So we've also compiled resources in the BioenergizeME Challenge Toolkit to assist students with the developing of their infographics, as well as the infographic guide. This infographic guide was developed specifically for the challenge to provide tips and guidance for creating an infographic. And don't forget to check out the challenge winners page and the bioenergy map to view past participants and winners. And just on the screen, I'll show you an example of how you can look at somebody's like a specific infographic from anywhere across the country. So you're going to go to the map that was on the right hand of the screen, and it'll bring you up to this page. From there, you can click one of the central nodes that has a number there. So in my case, I clicked up in the Northeast. From there, I clicked into the New York City region, and what that'll do, it'll bring you spirals of different color pointers, which are filtered by the different topic areas that the BioenergizeME infographics from past challenges have focused on. So specifically, I pulled up one of these green icons to see the winning infographic from last year's challenge called Cellulosic Ethanol, the Fuel of the Future. So each infographic should be reviewed and scored by the team advisors using the rubric provided, which I show on the screen here, and it's also available on the BioenergizeME website and toolkit. To ensure the accuracy of information and to help with reducing distribution of misinformation, team advisors should only submit infographics receiving at least 3 points in each of these categories. Well, specifically, at least 3 points in the research content category. The rubric in general, though, includes 3 categories, including research content, which involves evidence-based clear analysis and explanation, and logical flow, design, which includes aesthetics, the aesthetics only of font, color, shape, and correct use of data visualization, and the relevance of the graphics used, and mechanics, which generally include grammar and guideline and format. The team advisor may provide feedback on infographics that receive less than 3 points and give student teams the opportunity to rework and resubmit those infographics for a qualifying score. So the 4th step is to submit a bioenergy infographic. On the BioenergizeME website, you'll find a link that says submit team's infographics, which is near where you have to also click to register the teams. So if you see on the screen, you go to submit, and it brings you up to this screen where you can put all the information that we request. So when you're submitting an infographic, you need to make sure that the infographic meets the following qualifications. They must be in either JPEG or PNG format with a minimum width of 825 pixels. They must respond to 1 research prompt found in the annual update, and the advisors will have to input this topic area number when submitting the infographic. They must be image-led, using illustrations or graphics to communicate the team's research findings. This includes using appropriate imagery, such as not using corn kernels when discussing cellulosic biomass, which I'll discuss on the next slide. They must include source citations for all facts, numbers, and images, and should be referenced as footnotes at the bottom of the infographic. And if you're looking for examples on how to do this, please feel free to check out the infographics from last year. As well, they must be original work and suitable for general audiences. Now, this isn't all the rules that are associated with submitting an infographic, but we encourage you to check out the toolkit, which has all of the rules listed. So, second big major date that we have for you to remember, and that is team advisors should submit all infographics by Friday, March 3rd, 2017 at 5 p.m. Central Time in order to be considered for the next round of the social media campaign. Okay, so after you submit infographics, they go through a round of review. So to explain this, let me say that during this stage, the BioenergizeME team will review each infographic, every single one that's submitted, for proper messaging, which includes using proper mechanics, accurate research content, and relevant imagery. Specifically for relevant imagery, we are not judging for artistic ability. Let me repeat that. We are not judging for artistic ability. We understand that not everybody's a Picasso or a Renoir, so don't worry about that. We are looking for verifying that the images that are used in the infographic are conveying messaging that is consistent with the text. For example, infographics that use the images of yellow corn kernels rather than corn plants are inconsistent with messaging about advanced biofuels, which do not use feedstocks that compete with food and feed demands. So really, just to be in general here, just be sure to spell check, cite your sources, and use appropriate imagery, and you'll pass the stage with flying colors. So teams will have at least 1 full week to complete the required revisions. All required changes must be addressed in order for the team to advance the social media campaign. However, just to let you know, the BioenergizeME team reserves the right to disqualify teams from advancing if the required changes that we provide are not met. The team advisor will be contacted to inform teams who have submitted qualifying infographics that they should proceed with planning their social media campaign strategy. The selected infographics will be posted on the BioenergizeME infographic challenge map, and a link to the infographics will be provided to each team advisor. So the 5th step is to actually participate in the social media campaign. And like I said before, an official link unique to each submission will be provided to the team advisors. And advisors, when receiving those unique links, should instruct teams to share the links via their students' personal social media outlets. The social media campaign for this year is 11 days long and officially starts on Monday, April 10th, 2017 at 5 p.m. Central Time and runs until Friday, April 21st, 2017 at 5 p.m. Central Time. Up on the screen, you'll see the social media guide, which was developed specifically for this challenge to provide tips and guidance for students for planning and executing an awesome social media campaign. Finalists are determined by the number of unique page views to their infographic page, so encourage your social media networks to view the link in addition to liking and sharing the infographic. Infographics that have received more than 500 unique page views will qualify for the second round of reviews. So just to repeat, to emphasize, you must receive 500 unique page views to an infographic in order for it to move to the final round of review. So to help with this process, there will be a top 10 leaderboard standings posted on the BioenergizeME website that will be periodically updated throughout the entire social media campaign. So after the social media campaign ends, the qualifying infographics go through a second phase of review. And this is for all teams that have received 500 or more unique page views in the social media campaign. And during this review, the office's technical team and director will select the top 3 infographics based on the design and research content sections of the rubric. And remember, we're not judging artistic ability. The office director will then select the grand prize winner. After that, we will invite all teams that move forward from the social media campaign to attend the virtual awards ceremony. It's held typically in early May, and then the top 3 infographics will be announced. So the grand prize winner and 2 runners-up, as well as the winner of the social media campaign, or who got the most unique page views. So again, all teams who make it to the social media campaign will be part of a national promotion of infographics. All finalists, those who receive 500 or more unique page views in the social media campaign, will be recognized with official letters of recognition and certificates that we will send to you. The grand prize winning team will be recognized at the office's annual conference, which is held in Washington, D.C. in June of 2017. So we wanted to take a few seconds to introduce the winning teams from previous challenges. The 2015 BioenergizeME Challenge winner was a team of 5 ninth grade boys from Williamsburg High School of Architecture and Design in Brooklyn, New York. The team designed an infographic on cellulosic ethanol. The 2016 BioenergizeME Challenge winner team was a team of 4 10th grade girls from Smithtown High School East in St. James, New York. The team designed an infographic titled Cellulosic Ethanol, Fueling the Future. And the 2017 BioenergizeME Challenge could be you or one of your teams. So the topic areas, prompts, and questions in the 2017 BioenergizeME Infographic Challenge are designed to help guide teams in developing a linear visual narrative. Each infographic should respond to one of 5 research topics provided in the 2017 annual update, which are shown up on the screen. Each topic area includes prompts in bold that are foundational, broad, and open-ended to foster student-centered discovery. Included with the prompts are a series of questions that will help students develop their visual story. Thorough and well-developed infographic submissions typically address the questions within a given topic area. So our office has compiled a comprehensive list of resources organized by topic area. And these resources can be found in the BioenergizeME Research Guide. And remember that you can review all of the 2017 challenge topic areas and prompts at any time in the 2017 annual update document, which is on our website. So moving forward to talking about different information that's included in each of the topic areas. And this is the kind of the part where we go through an overview of bioenergy. But if you're looking for more of a Bioenergy Basics 101 or Biomass Basics, please feel free to check out our other webinars that we have on the Education and Workforce Development website. So our first topic area 1, is history of modern bioenergy. And the prompt is, discuss the progression of first-generation bioenergy feedstocks to next-generation or advanced bioenergy feedstocks. Some questions that could be answered include, what is bioenergy and what is biomass? And what is a feedstock? What is a first-generation feedstock? And what is a next-generation or advanced feedstock? Why have researchers expanded our biomass resources to include next-generation feedstocks? And what are the benefits and challenges that are associated with next-generation feedstocks? So to help you out, we've given you some cool information that may be able to help you answer these questions. So biomass is the organic material that has stored sunlight in the form of chemical energy. Plants can be thought of as warehouses for solar energy. Through photosynthesis, plants collect sunlight, carbon dioxide, and water and convert it into chemical energy in the form of sugars that are stored in their biomass. So bioenergy is a form of renewable energy derived from biomass to generate heat and electricity, also known as biopower, biofuels, which are transportation fuels, biochemicals, and other energy-related bioproducts that are produced from biomass. Bioenergy is energy that is produced from renewable biomass resources. Bioenergy does not include solar, wind, water, geothermal, or nuclear energy. Bioenergy also does not include non-renewable fossil energy sources such as coal, oil, or natural gas. Biomass that is used for bioenergy production is called a feedstock. There are many different types of feedstocks that can be utilized for bioenergy. For example, the biofuel ethanol, which is made from corn, represents the first generation of biofuels. Now, the Department of Energy is focusing on new technologies to make biofuels and bioenergy from many non-food, feed, fiber sources, such as corn cobs and stalks, also known as stover, wood byproducts, municipal waste, and algae. Ethanol that is produced from cellulosic materials and non-food, feed, fiber sources is called cellulosic ethanol. Cellulosic ethanol and bioenergy made from non-food, feed, fiber sources are part of the next generation of bioenergy. There are 5 different types of feedstocks that are primarily used for next generation bioenergy production, and those include agricultural residues, forest residues, energy crops, algae, and municipal solid waste. So agricultural residues are plant parts left behind in the field after harvest. This plant matter and secondary residues like manure and food processing waste can be useful feedstocks. Energy crops are fast-growing trees and perennial grasses that are specifically grown for energy uses. Trees and perennial grasses can often be grown on land that is less suitable for conventional crops and can stabilize the soil. Forest residues are leftover wood or plant material from logging operations, forest management, and land clearing. Secondary residues like mill waste supplement this category. Municipal solid waste, such as dead leaves, food scraps, and other garbage that is thrown out, has the potential to also be a bioenergy feedstock. And finally, but not least, many macroalgae, or the big seaweed that's in the oceans, microalgae, the tiny microscopic organisms, and cyanobacteria, which is another form of microalgae, carry out photosynthesis to drive rapid biomass growth. Algae biomass can contain high levels of oil, making it a promising feedstock for biofuels, including renewable gasoline. So, kind of going back to Biology 101 here, there are 3 types of macromolecules, or large molecules that are basic building blocks of everything that are primarily associated with bioenergy: carbohydrates, lipids, and proteins. Now, carbohydrates, just to summarize, are molecules that contain sugars and starches. Starches are the most common carbohydrate in the human diet. The biofuel ethanol is also made from carbohydrates. Lipids are macromolecules that contain oils and fats. Both plants and animals have lipids, which serve as an energy storage facility and add a structural component of cell membranes. The biofuel biodiesel is composed of lipids. Proteins are chains of amino acids that have a variety of functions, including acting as catalysts in chemical reactions, DNA creation, and the transport of other molecules. One particular protein, an enzyme called cellulase, is important for bioenergy because it breaks down cellulose molecules in the biomass into simple sugars, which can then be converted into a finished product. Proteins are also important to bioenergy as they can be synthesized into bioproducts. Now, what the Department of Energy is trying to get at is the non-food feed fiber components of the plant structure. These are mostly made out of a biomolecule called cellulose. I have referenced this before. So if you think back to the first units of biology, you'll remember that cellulose is a carbohydrate macromolecule composed of many repeating glucose units. Essentially, we are trying to access those sugar units because we can chemically rearrange them into fuels. But it's really tough to break them down, and really tough. And it's packed tightly with other plant cells, cell wall molecules. So the challenge for the Department of Energy is to break down that tough structure and get at that sugar. To kind of summarize it more in a simpler way is that it's like taking a sledgehammer to a steel beam of a house frame. It takes a while and it is difficult to tear down. So moving on to topic area 2, which is sustainability, where we're focusing on, in general terms, talking about sustainability as the capacity of systems and processes to endure and thrive. Sustainable development seeks to balance economic development, social development, and environmental protection equally. So we're asking students to discuss the concept of sustainability as it applies to the development of bioenergy systems. And some questions that you may want to think about include how you define sustainability in the context of bioenergy, what natural resources should be considered when planning and implementing a sustainable bioenergy landscape, and then what are the potential benefits, the environmental, social, and economic benefits, of a growing sustainable biomass resource. So I see we have a question. If you could wait to the end, that would be great, and I will be more than happy to answer your question. So the existing emerging bioenergy industry will need to develop systems that not only meet economic and market needs, but also address environmental and social aspects such as resource availability, and public acceptance. So next generation feedstocks, such as agricultural and forest residues, dedicated energy crops, organic non-recycled municipal solid waste, and algae are being developed in a way that requires minimal water, fertilizer, land use, and other inputs. Backed by the Energy Independence and Security Act of 2007, growth in the United States biofuel industry has contributed to a substantial number of green-collar workforce jobs. In 2012, the ethanol industry supported an estimated 383,000 jobs, including feedstock production, construction, and research. Expanding sustainable bioenergy production requires a consideration of impacts on quantity and quality of water throughout the entire bioenergy supply chain. Sustainable bioenergy production will rely on aligning water demands with water availability, protecting water supplies within aquatic ecosystems, and maximizing the use of impaired, rather than pristine, water for producing biomass. Producing biomass requires healthy soil that maintains productivity over time. Sustainable soil health involves minimizing soil erosion, maintaining soil carbon and other essential nutrients, and protecting the soil's physical and biological attributes. The harvest of forest and crop residues should be managed to maintain soil quality. In addition, several bioenergy feedstocks currently being considered, such as perennial grasses, show strong potential for increasing soil carbon and reducing erosion. Growing biomass for bioenergy can either improve or reduce the diversity of plant and wildlife populations depending on where it is grown, the existing land cover, and the way the land has been used. For example, growing native grasses on degraded land can provide improved habitats for wildlife. Alternatively, growing feedstock in place of healthy habitats can diminish biodiversity. Bioenergy offers significant potential to mitigate climate change by reducing life cycle greenhouse emissions relative to fossil fuels. Although producing and burning biomass-based fuels releases carbon dioxide, biomass absorbs carbon dioxide from the atmosphere as it grows. In contrast, using fossil fuels releases significant volumes of newly released carbon to the atmosphere. The burning of fossil fuels creates a net positive increase in atmospheric carbon. So let's put everything that's just been discussed into perspective. On the right-hand side is a scenario that we are aiming towards, a sustainable bioenergy system. This would lead to increased biodiversity and wildlife habitat, increased soil organic carbon, reduced soil erosion, reduced fertilizer use and leaching, and lower emissions from fertilizer use and improved water quality. As well, there are important socioeconomic benefits such as increased food security and increased sustainable rural development. And finally, of course, a decrease in emissions. If we don't sustainably manage bioenergy, we'll see something like in the left panel. The scenario is depicting what a poorly managed bioenergy production system would look like. This would mean using unsustainable land management practices and/or seeing a conversion of perennial ecosystems to intensive agricultural practices. This would cause a loss of biodiversity and wildlife habitat, decreased soil organic carbon, increased soil erosion, increased fertilizer use and leaching, as well as increased emissions from use of fertilizer and damaged water quality. On top of that, there would still be increasing emissions. So it's important to understand that we are already seeing these types of impacts with conventional agriculture. So topic area 3, bioenergy in society. Here we define a sustainable transportation system is one that is accessible, affordable, efficient, and achieves the highest practical standards for safety, human health, and environmental quality. We're asking students to discuss the role of bioenergy in the overall vision of sustainable transportation. And some questions you may want to consider include, what is the role that bioenergy plays in the development of sustainable transportation systems? How bioenergy technologies can help meet sustainable transportation goals? And really discussing or illustrating whether the current transportation system is sustainable in the context of energy consumption, environmental impact, and the national global economy. So to give you a little bit of a background, according to the Energy Information Agency, or EIA, petroleum, natural gas, coal, renewable energy, and nuclear electric power are primary sources of energy. Electricity is a secondary energy source that is generated from primary sources of energy. Energy sources are measured in different physical units. Liquid fuels are in barrels or gallons, natural gases in cubic feet, coal in short tons, and electricity in kilowatts and kilowatt hours. In the United States, British thermal units, also acronymed as BTU, is a measure of heat energy and is commonly used for comparing different types of energy to each other. Now, in 2015, the total U.S. primary energy consumption was about 97.7 quadrillion, or 10 to the 15, or 1,000 trillion BTU. Of that 97.7 quadrillion, 9.7 quadrillion, or 10% of the energy consumed was renewable energy. And just a fun fact, biomass comprised 49% of that renewable energy percentage. All things need energy, including each sector of our economy. The industrial sector includes facilities and equipment used for manufacturing, agriculture, mining, and construction. The transportation sector includes vehicles that transport people and goods. And petroleum is the most widely used energy resource for transportation. The residential sector consists of homes and apartments and is lumped with the commercial sector, which includes offices, malls, stores, schools, etc. And the electric power sector uses energy to generate electricity. Again, according to the Energy Information Agency, in 2015, the shares of total primary energy consumption of the 5 energy-consuming sectors were 39% for electric power, 28% for transportation, 22% for industrial, 7% for residential, and 4% for commercial. So the electric power sector generates most of the electricity in the United States, and the other 4 sectors consume most of the electricity it produces, or it consumes. In the chart shown on the screen, the Energy Information Agency is depicting lines that connect the primary energy sources on the left with the demand sectors on the right, and the graphic shows the links between energy sources and sector uses in the United States. For example, because all nuclear energy is used in the electric power sector to generate electricity, and because nuclear represents 22% of the primary energy that's used by that sector, the line between nuclear energy and the electric power sector shows 100% for nuclear energy in the source column and 22% for electric power in the sector column. The mix of primary energy sources varies widely across demand sectors. Energy policies designed to influence the use of a particular primary energy source for environmental, economic, or energy security reasons often focus on sectors that are major users of that energy source. For example, because 72% of petroleum is used in the transportation sector, where it provides 92% of the total primary energy used, policies to reduce petroleum consumption often focus on the transportation sector. These policies usually seek to increase vehicle fuel efficiency or promote alternative fuels. About 91% of coal, but only 1% of petroleum, is actually used to generate electricity, which means policies affecting electricity generation are likely to have a much larger impact on coal use than on petroleum use. Some primary energy sources, such as nuclear and coal, are entirely or predominantly used in one sector. Others, like natural gas and renewables, are more evenly distributed across sectors. Similarly, while transportation is almost entirely dependent on one fuel, which is petroleum, the electric power sector uses a variety of energy sources for generating electricity. So the links between these sectors and the energy sources consumed in those sectors change over time, but the changes tend to occur slowly. For example, coal was once used extensively as a fuel for heating homes and commercial buildings, but that specific use of coal has decreased to almost nothing in the United States over the past half-century. Although renewable energy's share of the total primary energy consumed in the United States is still relatively small, its use is growing across all sectors. Also, natural gas use in the electric power sector has increased in recent years because of lower natural gas prices, while the use of coal in that sector has declined. Now, I know that was a lot of data information, so to kind of sum it up in what sustainable transportation means to the U.S. Department of Energy can be summarized in 3 points. One is to increase national security, which means reduce the dependence on imported petroleum, to promote the use of diverse, domestic, and sustainable energy sources, and to increase the reliability and efficiency of electricity generation. The second point is to support U.S. rural and urban economies. Within that, it's including establishing and maintaining a domestic workforce in manufacturing, scientific research, construction, agriculture, plant operations, and sales, as well as reducing transportation costs for businesses and consumers. The final point is to promote public health and the environment by reducing emissions from vehicles, energy production and consumption, and investigating the potential of growing sustainable feedstocks for biofuels. Now, specifically for bioenergy, its role in sustainable transportation is to promote national security through developing domestic sources of energy or homegrown sources of energy, growing a sustainable future with renewable biomass resources, and generating green jobs by stimulating the bioenergy economy or the bioeconomy. So looking towards the future, if we're able to produce 1 billion dry tons of sustainable biomass, it has the potential to produce over 1 million domestic jobs, enough electricity to power 6 million households, displace almost 25% of all transportation fuels, replace a significant portion of the chemical market, and reduce 400 million tons of CO2 equivalent annually. So moving on to topic area 4, which covers workforce and education. And here we go more into the definition of what is the bioeconomy. So we define the bioeconomy as an emerging part of the U.S. economy that relies on the renewable biological resources to produce fuel, power, and bio-based products. For this industry to thrive, it will require the development of a diverse and skilled workforce. So we are asking students to discuss the bioenergy-related educational programs as well as the characteristics of the workforce needed to support that growing industry, including answering some questions like what fields of study could lead to a career in bioenergy, researching a higher education program in bioenergy or job training institution in your state, and how can skills and knowledge gained from this institution or program apply to a career in bioenergy? And then what are some of the non-traditional fields of study that could lead to a career in bioenergy? While I'm not going to cover any of the specific institutions that focus on bioenergy programs, because there are many and across the United States, I will give you some examples of what type of jobs are in each subsector of the bioenergy industry. So within the research sector, there is chemical engineers, chemical application specialists, chemical production workers, biochemists, genetic engineers, and scientists. So think of it as research and development, scientists, and engineers. So for biomass supply and logistics, or growing the biomass and then cutting it down, breaking it down, and moving it across the country in trucks and infrastructure, you would include farmers and seasonal workers, tree farm workers, mechanical engineers, harvesting equipment mechanics, equipment production workers, agricultural engineers, and storage facility operators. So for conversion, or taking the biomass from a solid feedstock and making it into a liquid fuel, you would need microbiologists, clean room technicians, industrial engineers, chemical and mechanical engineers, and plant operators. And then to get the end product to consumers like us, you need gas station workers, codes and standards developers, regulation compliance workers, and entrepreneurs. As well, we need people to build the infrastructure that will handle the bioenergy system. So we're looking at construction workers, truck drivers, barge operators, and rail operators. So finally, we get into topic area 5, which is science and technology. So this has a lot of text on this slide, and I don't want you to be afraid of this topic. It may seem like there are a lot of tough words or unfamiliar concepts, but we've had lots of participants and students love to do this topic and learning about the science behind taking a feedstock to a general finished product. So what we're asking here is that there are many technology pathways that are used to convert non-food feed fiber or the advanced bioenergy feedstocks into final products. And we've given 5 of these technology pathways, and we want students to illustrate how to go from a feedstock to a final product. So in general, there are 5 steps to turning biomass into bioenergy. There's feedstock supply and harvesting, so that is the growing of the feedstock, harvesting it, and then transportation of the feedstock to a conversion facility, also called a biorefinery, where it goes from a solid feedstock to a liquid fuel. And then there's the distribution of those fuels and end products at gas stations, stores, and other places. And then the final step is the actual consumption of the fuels and products by consumers like you and me. So to define what a biorefinery is, it's where a solid feedstock is converted into a finished product or fuel. So first, the biomass is brought to the biorefinery and is treated with heat and chemicals, which help dry the biomass and get it ready for the next step of breaking it down even further. Next, the treated biomass moves into a tank where enzymes are added to break down the cellulose and the biomass into simple sugars. Those simple sugars are then fermented in a tank by microbes, which creates ethanol. And finally, the ethanol is cleaned and purified in preparation for distribution to gas stations, airports, and other uses. So for low temperature conversion, which is, is one of the, is topic number 5, or is the, topic number 5 of the topic area 5. So cellulosic biomass to renewable hydrocarbon fuels, or thermochemical conversion process. The biomass goes through a pre-treatment process, and then which opens up the plant cell wall, making organic polymers or sugars more accessible. Those large sugar polymers are then split into smaller individual sugar units, like glucose, by enzymes in a process called hydrolysis. Those individual sugar units are then converted by microbes through fermentation, like the process we just discussed, into cellulosic ethanol or renewable gasoline, diesel, and jet fuel. Now, for high temperature conversion, or number 4 of topic area 5, so cellulosic biomass to renewable hydrocarbon fuels, or biochemical conversion pathways. The biomass goes through a pretreatment process, which opens up the plant cell wall, making organic polymers like sugars. Oh, I'm sorry. The biomass is deconstructed using extreme heat and pressure, such as processes like pyrolysis, gasification, and hydrothermal liquefaction, into a liquid biooil or gaseous intermediates. And then those intermediates are then upgraded to finished fuels for use using chemical catalysts in an upgrading process. So again, I don't want you to be bogged down by how many big concepts are in here, and a lot of it is very science and technology based, but this is a really good way to engage students in science and in biology and chemical processes that are you're teaching in your curriculum. So finally, before we get to questions, I wanted to talk a little bit or reemphasize some of the resources that will help teams get started in the 2017 challenge. First, don't forget about the Bioenergy Resource Guide. These are resources that we found that will assist in answering these topic prompts and questions and will lead teams to further information sources that can be used. Also remember that the toolkit covers all of the rules, the guidelines, and steps to participate in the BioenergizeME Infographic Challenge, from how to create an infographic, review procedures, and how to create a social media campaign. And remember, this is a creative process, so be imaginative and have fun. There is no one-size-fits-all winner in the BioenergizeME Infographic Challenge. And these are all of the entries that we had, or submissions from the 2016 BioenergizeME Challenge, which you can find on our website. And finally, remember that the BioenergizeME team is always available to talk via email. No question is a bad question. If you want to learn more about bioenergy and how to integrate it into the classroom, you can feel free to check out the Education and Workforce Development homepage, which is listed on the slide. And finally, thank you for participating in this webinar. And with that, I'm happy to answer any questions that you may have. So the first question that we have here is wondering if Canadian teams were allowed to compete. Unfortunately, right now, we are only U.S. citizens are allowed to compete. But we encourage you to use the other resources and tools that are on our website to integrate bioenergy into the classroom. So another person has asked whether to have me repeat the important dates that are part of the 2017 challenge. So teams must register advisors must register their teams by February 3rd, 2017, 5 p.m. Central Time. Teams must submit those infographics then by March 3rd, 2017 at 5 p.m. Central Time. Then the social media campaign is from April 10th to the 21st, I believe, and it's 11 days, and you must get 500 unique page views in order to move on to the final stage of review. Then the virtual award ceremony is in early May. We want all people who advance from the social media campaign to attend there so they can see if they were picked as the grand prize winner. The grand prize winner is then brought to Washington, D.C. To participate in the annual Bioenergy Conference. And last year was really special because we were able to provide a really cool package for the winners where they were able to tour the Library of Congress and the Science Reading Room. They had a private tour with their state representative and the U.S. Capitol, as well as going to some of the museums and the Supreme Court. But the really cool part about winning the BioenergizeME Challenge is that these students get to interact with the scientists and engineers that are on the ground working on bioenergy research and development. And they get to talk about internships, career opportunities, like some of the nitty-gritty science they learned during the BioenergizeME Challenge. So really, it's a great opportunity for students to engage in America's energy future. So the next question is, will this webinar be archived somewhere online? Yes, this is definitely archived. I'm recording it right now. It usually takes us between 1 to 2 weeks to get it up, but it will be up on our website eternally. So you can access it, I would say, safely, probably by the end of the month, early December. And feel free to use this for, like, as a resource when you're creating infographics. So with that, it is close to 5 o'clock, and I don't want to keep everybody. So thank you so much for participating in this. And as always, if you have any more questions or concerns or want to learn more about bioenergy, feel free to email us at bioenergizeme@ee.doe.gov. Have a great day and have a great holiday season.